today we will go to the last part of this topic, this like a hand-on and science communication. So we will summarize a bit what we have seen yesterday about how important is science communication in our society, both in the level of peer reviewing, like the paper that we write to communicate our scientific research and findings, but also how we communicate with people, like the general audience, and how it's important to like go out from the lab, from your theory team or whatever, and try to like to reach the community that at the end make possible for us to make science in our country. So it is a very important deal. So we have talked a bit about that. We have talked about how normally it's way more than just speaking good English in this case. So a lot of the scientific communication that we do is in English because of the peer review and stuff. Maybe in our countries it's in our native language, but at the end it's way more than that. We can all have broken English to communicate, but at the end of the day, there are techniques that we can learn and try to communicate better. Okay, so this is something that we have go through yesterday. So this is this, and then we also saw this picture that is very important. When you are presenting your work anywhere, you need to know your audience. This is important. It's the first question that you have to ask to the organizers or whatever. Whoever is asking you to give a presentation, you need to know your audience. It's not the same like speaking to like students, like in quantum optics field, or to a seminar where you will know that there is a lot of professors in different topics. So it is important to know to who you are like giving your talk. And we also talk a bit on how to create the value. So I try to communicate that is way more than just speaking out our mind and share our ideas. You want the people to value what you are doing. So you need to add value to your presentations, to your papers, to your findings, etc. So we talk a bit about that, and a way to do that is actually try to think how your audience is thinking, and try to present them. This is the problem at the end. Like try to acknowledge what your audience is thinking. So we have seen that yesterday too, and we have these tips for presenting ideas that we should usually try to imagine this like a pyramid, inverted pyramid, and try to see what is the broader problem, the narrow problem, what we have actually done to solve this narrow problem that tributes to the broader problem, and then also try to communicate the key findings of our work and the implications. So it's like it's like a pyramid, but then at the end it opens back and communicate again with the broader problem. So this is the idea of how you can like the through line of your talk. And then we have shared also some like tips for oral communication. So we have talked about that you could imagine like your talk or your paper like a tree, and then you are explaining how this tree is built up. At the end, you have to adjust your message to the audience. So, for example, if you want to share the findings of your paper to like a seminar, then you need to adapt the message of your paper to the seminar. So you need to know how to do that. You can also use your body, right? Your voice. The body, we have talked about this power pose in order to soltar, I don't know how to say that, but like to communicate better, like in more freedom. The rhythm that you're using, the movement, not exaggerate either, because at the end you don't want people just to focus on you, but on your message. So this is important too. We have talked also about how to have a high impact slides, so how to make them minimal for the reader not to be so tiring when you are like presenting your research. So you have to have the well-chosen information, and you need to know your graphics, your tables, whatever you are presenting here, you need to know how to explain that. And if you put something, it's because you will use it, so to say. And even if at some point you cannot use it because the time is running and you have to go fast, if someone asks you at the end of the presentation, what's this graphic about, you need to know how to present your data. And also, at the end of the lecture yesterday, we also talked a bit about can we prepare to questions. because at the end of the day, it's very normal in your stage that you are a bit nervous when you have to present like to someone, especially if you know there is like supervisors or professors or other or just mates that they do not like you very much, and they can ask you like difficult questions, and you need to know how to, you need to be prepared because this can happen, and you can have some techniques on how you can answer this question and how you can bring back the attention to you and to your message, and try to like to tell people like, okay, this is a very good point, we can discuss later in the coffee break and stuff like that. So we have talked about this yesterday. So today, the idea is that I want to describe a bit how to structure a paper, especially a paper, and then this will be like a half of the time talking about this, and then the other half will be really you to be working on your flash talks presentation. That the idea will be for you to share them tomorrow here in front of us. That's the idea. So I know that this can be, that you can get very nervous about that, and you might be thinking like, okay, maybe I don't want to be in front, but at the end of the day, I really encourage you to take the opportunity to be here because you can learn. You can really learn, and this is a safe space where you can like prove your skills and you can improve. There is no other way of improving your oral presentations and skills without practicing. This is not going to happen. So the most chances you have to practice and to be here in front of people that know you, don't know you, professors that will be here in the audience, is good for you. So take the opportunity. We have like 30 spots because the idea will be to have a presentation, like 3 minutes presentation for tomorrow. So I will give you later my email because the idea is that tonight or tomorrow, let's say before 9 a.m., for you to send me the presentations in PDF, and then we go with the 30 presentations. So we have 90 minutes, so 30 presentations of 3 minutes. So it won't be a space for everyone, but the idea is that for you to volunteer to be here. I don't want to press anyone to be here, of course, but I really encourage you to take the opportunity, okay? So this will be the idea of the lecture today. So first, I wanted to share with you some pages, like web pages or like resources for you to, when you have to find important information about papers, okay? So, of course, Google Scholar is a very good one. It's very fast, Google Scholar. So the papers that we upload in archive or stuff like that or in conference appear very quickly in Google Scholar, way faster than in Web of Science. So normally you can reach and get a lot of information there. So I really encourage you to use that. Archive, of course, archive should be such an important thing for you that the first 10 minutes of your mornings, every morning, like between Monday and Friday, you should take 10 or 15 minutes to see what is going on in your field. This has to be like a habit. When I was doing my PhD and also my postdoc, this was everyday basis. I was like turning on the laser and then go to the archive, especially to the quantum whatever stuff. And then with a coffee, and you go through the titles, the abstract. Of course, you will not read the 20 papers that has been like uploaded during that day, but you still can see the titles, and if you find something interesting, you can go to the abstract and like this. But this is a very good habit because then you can connect with what other people is doing in your field, other teams, and then you will see this happens. Like you go through, oh, okay, I know this guy, I met him in another conference, and then I know, okay, he was working on that, and now he has his paper on, and so on. So it's important for you to have this habit. It should be something that you do every day. Paper Escape is another web page that helps you to find some information and like following up some paper. Web of Science also, but for me particular, this is my personal opinion, but for me it's not very useful in the sense that it's too slow. It's like slow. It's like the papers appear them very late, like it can have a delay of 3 months, 6 months, or at the end of the day, I use Google Scholar, which for me is way faster. The Academic Phrase Bank is also a web page where you can have some academic phrase bank. The Grammarly was widely used before ChatGPT because it teaches you what you could in Grammarly you could put like a paragraph, and Grammarly will suggest you to have some changes to improve your writing. So it is a really good tool. ChatGPT also, I will talk a bit about this in the next slide, but I think that we are allowed to use AI in order to improve our writing and how to structure ideas and stuff like that. And I think that at the bottom line, with any AI, you have an ethic problem, but this can be like transferred in any other topic. So first you need to like work on your ethic, and then probably any tool will be very useful to you if you know how to use it, okay? And then this one, the last one, the notebook KLM, is really good. I really like it. This one is an AI where you can like upload several, for example, papers on quantum key distribution, like all the Steve's papers. And then you just upload all the Steve's papers there, and you can ask this AI to generate a postcard. It can generate like a 10-minute podcast. It's really good, very naturally speaking. I have tried it with my papers, and it's really good. So it takes the key message of our findings. And also you can ask questions about, like, for example, if you want to see in all Steve's paper, what is the faster way of doing I don't know what, and then this AI can answer you because you have uploaded all the papers in the data in the base. So it's a really good tool. I use it a lot. And about the AI, I wanted to refer a bit. So in Nature this year, at the beginning of the year, it appeared like how to say, encuesta, like a doodle or something like that, where the Nature was asking to a lot of professors, I think that they were all PIs or people that published there, about the use of AI. And you can take it also. So it's still open, so you can just go and you can like answer the question. And then each time that you answer one question, the Nature is comparing your answer with the answer of this bunch of people that did it before you, okay? So this is the idea. And for me, it was quite surprising. It's not quite surprising in the sense that, of course, you will have different opinions on how to use AI and if is it good or not, or ethically to be using that. But it's a split, the opinion. It is a split. And in my personal opinion, I think, again, that this kind of answers, when someone says to you, no, you cannot use AI because it's like against ethical, I don't know what, I think, again, they do not realize that not everyone has a native speaker speaking English. So for us, it's very useful. I don't have the money to hire someone to review my paper and all the Grammarly, all the mistakes that I could make. But of course, the AI in that sense can help me. So of course, it's not ethical if I said to the AI, write my paper. Of course, it's not. But if you are using it like, okay, this is my paper, this is my intro, can you please hear, for example, the AI, can you read the paper that I have? And for you, what is the key message? What is the highlighting thing that you are like reading on what I have just written? So these kind of things you can use AI, and I think it's very important. So I think sometimes in this kind of encuestas or whatever, you are missing that not everyone has the same level of English or resources to be helping you in how to write down your research activities. So it's a very good exercise. You can go there. As I said, you can answer the question and you can be compared with these other 5,000 research answers. Okay, so what we will go through now is about how we can structure a scientific paper. So the first thing that we will talk about is about the title, the abstract, and the keywords that are very important. Yeah, it's way important to be able to build up with value in order for people to get engaged with your finding, with your work, okay? So the title, in principle, the title provides the first impression of your research. It's the primary way readers decide if they should delve deeper into your work or not. So the title has to be informative, has to be appealing, of course, and it grabs the attention of the audience at the end. So you will see, when you go and do this exercise about looking to archive every day, you will see that some titles are appealing and you want to go, oh, this is very interesting. You will find yourself in such a moment where you see, okay, I don't do that, but still I want to read this paper because the title is very engaging and I want to know more about what this group is doing, okay? And of course, it should offer a snapshot of the research main topic, of course, okay? So often, people read only the title, the abstract, and the figures. It's something that we have said yesterday, okay? So the title have to be clear and concise. Of course, you have to avoid jargon, ensure that the researchers outside your niche understands the topic. This is depend, again, on the journal, of course. There are some journals that they want you to have like a broadened picture, especially in the title and in the abstract. Some others are way more technical. Say to you, okay, no, skip all this thing and just go to the point. So this really depends on the journal. But of course, the first thing that you need to know when you are trying to write a paper is imagine, or at least have a list of the possible journals where your finding can be published or where you will send them later, okay? This is important to see. Make it informative. We have said this yesterday when we were like, trying to have some tips about how to make meaningful slides. So the title of the slides, and again, of course, the title of your paper is good if it is informative. This is very good. It can like take the attention of the audience and keep it, of course, engagement. But you want to avoid sensationalism. And this is, I do this meme that I saw in social media a long time ago. But this, I mean, you don't want your paper to be like the title of the abstract, and then you see the paper, and it's like thin and without the same strength that you were trying to communicate in your title and in your abstract, okay? So you need to like have this image in mind and try to do better. Then the abstract has the purpose of provide a brief summary of what you have done in your research. So you will have, depends again on the journal, but the idea is there to show the broader problem, the narrow problem, what you have done, and then the key implications, the key perspective, a message, whatever. So this again depends a little bit on the journal. But it is important because it will be the first like glimpse of the readers when they are trying to decide whether they will read your whole thing or will just stop there. So it is important, and also helps a lot in the research and navigation. You will see that when you are writing your own papers for the first time or the second you will have to look in the like to enrich your introduction. You will need to find good papers, like updated papers on your field. So then you will find very useful to have good titles and good abstract to decide whether you will keep reading this paper and then add you to your introduction. For example, for me, when I receive papers to review, this is something that I pay a lot of attention. If I see the introduction that all the references are like 5-10 years ago, for me, it's like a red flag. No, but if you are like trying to build science like in the state of the art, then why you have so old reference? You need to find better reference, better in the sense of new, not better in the sense of the content. Okay? So the most important take-home message should be in your abstract, of course, and also in the title. You have to tribute to your key message. So some tips in order to write this abstract. So first you need to know, or at least to know the word limits. So in some journals, you have a word limit on the abstract, and in some others, you have a structure to follow. Like in Nature, you have a structure to follow, okay? So you need to know that. Otherwise, it can happen to you that you prepare your whole thing and your draft, and then you, no, I want to send it to PRL, and then you go, and you see that it's like a 600, I don't know, characters word, I don't remember exactly, that you have to, like, within that for the abstract. And then you have to, again, think again how you are writing this in order to be within this word limit. So you want to highlight your key points. You want to avoid unnecessary details. Yesterday we saw some example. I hope that they will upload all this lesson today because I sent them yesterday at 3 p.m. So I hope that they will do it today. And then we saw some abstracts examples, and we saw one in particular where you have formulas and stuff, and it's immediately, okay, I don't want to keep reading this. You see? So you want to avoid unnecessary detail, and you want to keep the attention on the broader, narrow, and what you have done and what is open from your findings, okay? And also you want to write clearly. This is very important, the right use of the words and stuff like that, okay? And for organizing the ideas of the abstract, is again very important to follow this structure that we have discussed: the broaden problem, the narrow problem, the central message, the key findings, the key implications. Okay, that this was we have done. We have seen this before. The keywords is something I'm not super sure how useful are the keywords, in the sense I have not found, for example, a paper or something that talks about how important the keywords are in a paper. But still, the keywords have the purpose of like to encapsulate, so to say, your topic, what you will be referring on this paper. And it's good sometimes when you are funding, for example, well, at some point when some of you might become editors of some journal, you will see that you will need to to find people that could be willing to review some paper. And then it's good to have this match. Okay, so if this guy is working in quantum key distribution and this paper is about quantum communication, so probably you can send this paper to this guy, okay? So this is the idea. So it helps with the searchability, discoverability, and also helps refer the referees to accept or not a paper, okay? And now we will focus a bit more in how we can structure a paper. So it's not completely, again, it's not completely a pyramid like this. It's kind of broadened again back to the beginning. This method is called the IMRAD, and I put a C, like a PhD candidate, but it's not true. I just add the C because in some papers you can have a division between discussion and conclusions, just that, okay? So the introduction, the purpose of the introduction is to introduce the background and the context of the research. It has to have like the state of the art of your research topic field. That's why you normally go again with the broad problem, the narrow problem. And I was telling you yesterday that normally the first paragraph you will see is the broad problem, then the second paragraph is the narrow problem. And then sometimes in the narrow problem you can have one paragraph or sometimes two. Sometimes you do like a 3-step until you can narrow the thing to the point where you can say, and in this paper we have... Okay, so the idea is to go from the most general thing to the most specific. This is the structure that the introduction should have. So you have to go to the background, so overview the existing literature of the current state of the topic. You have to have the problem statement, of course. You need to know what you are solving and why this is important to be solved, and why your suggestion, proposition, or work is important or is doing what you think is doing to solve this problem that is important to the community. And of course, it has to be objective in the sense that clearly states the purpose of the study or the research question being addressed. You have to be clear on that. So you have to be consistent, avoid overly technical jargon, establish the relevance of your research to engage your audience. This is the idea of the abstract, so the introduction. And again, go in the same. Like at the end of the day, the introduction is like broadening your own abstract at the end of the day. So it has the same structure. But you can add here, of course, in the introduction, at some point you will say, okay, in this paper we show blah, 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 and then at some point you will also talk a bit of how the paper is organized. This is also very useful at the end. You can, especially if you have very long papers, so you can say, okay, in section 1 we will discuss blah, blah, blah. In section 2, and we will end with some conclusions and I don't know what. Okay, so this is also goes in the introduction. So the introduction summarizes the state of the art and gives the context of why this research is relevant and worth publishing. You have to keep in mind that when we receive your paper, the first question that the editor asks is whether this work is worth publishing and is worth publishing in this journal. This is a specific question that we get. So as the ones that review the papers, we of course need to know the scope of the journal. Otherwise, we cannot judge whether this should be published here or somewhere else, okay? So you need to know that someone will be asking this question when reading your work. So it's important to do. Then normally, you have a second section, which is the methodology, okay? So again, here the purpose describes how the research was conducted. This is like the recipe. and you have to start from something that it is known to something that is unknown and is actually your work. But it's important to start like this. It's hard when you are presenting, for example, a new method or quantifying the gravity. I don't know. It's hard if you just put the new and you don't construct your methodology from something that is known to other people. It's hard to follow for the reader. So it's important to go from somewhere that you know the thing and then to present the unknown later. So this is important. The components of the methodology, normally have the participants of subject. That is not very usual thing for us because we don't work with animals or people. There are some physicists that work on this field that is called complex phenomena, and they try to apply physical models and stuff to human behavior, and then they have to do all this stuff. They have to present what was the subject of a study, people from age, I don't know, these kind of things. For us, it could be more about that. For example, if it is an experimental paper, then there is where you can try to explain what was the equipment, the tooling that you have used, etc. So this goes here. The procedure, of course, this is like a recipe at the end of the day. So you want this to ensure that someone else can reproduce your findings. Because at the end of the day, remember that when we are publishing papers, what you really want to do is to prove that your finding is true, and then someone else can reproduce your findings. Otherwise, you can go and patent your thing. If you don't want to reveal the secret of whatever, then there is another direction to follow. But for the science communication, in that sense, on the peer science communication, you want people to know what you have done, that is good, and then that people can reproduce the result and build from there, build up the new horizon of knowledge. So it is important to keep in mind when you are writing your methodology that this has to be there. Then you can have the data analysis, but actually I do not mean the discussions or the results. I mean, for example, how you have taken your data. For example, we have a paper in 2019 that we sent to optics later that I don't like it very much because it's too short, so you have the impression that you cannot explain what you have done. But okay, this is another topic. But then, for example, we were working on how a refractive photonic crystal can create extreme events. And so there, in the methodology, we have to explain this procedure. Okay, so we were waiting, to put in a lot of power and voltage in the crystal, and then wait, I don't know how many minutes, and after that timing, we were taking the images of the system, and then every image has been taken in the same way in order to be comparative later, stuff like that. So this goes in your methodology, because at the end, you are talking to the people your recipe of how you were taking this data. So the guidance here is to ensure clarity, as this section allows others to replicate your study, avoid unnecessary detail. You need to keep in mind also that you have, how to cut this, los anexos, the annex of the paper, so you can add information that it might not be so relevant in the main text, and you can put it in the later in the annexes on the supplemental material, depends on the journal, okay? So at the end, what is important here is to let the flow flows. This is the important thing. You need to know, this is a very good example to read it aloud and to see if the people is not losing the main structure idea that you want to present. This is a very good test in order to recognize, okay, I should not put this step of the equation. This can go directly to the supplemental material, and I can just say, okay, to go from here to there, to explain what you have done, but then if someone wants to see the details, they should go to the supplemental material, okay? So this is the idea. So as I said, it's like a recipe of the article. You have to give everything so that the results can be replicated and verified. It should not read too heavy, and you can use the appendix for that. I said annexos, like appendix. Then you have the section of the results, and sometimes results is different than discussion. So here I will explain them differently, although sometimes you can have section that is called results and discussions, but I will try to make the difference here. So in the results, the purpose is to present the findings of your research. You must present it clearly, and consider people also disabilities. This is something that most people not always pay attention, but you have to remember there are people that have problems recognizing colors and stuff. So ideally will be when you imagine to print it out your figure, for example, in white and black, and see if people can recognize your levels and your curves, even if they don't have the colors, for example. So it's a good thing to try to do that. And also the figures, the idea is not then to be so heavy. There are people that works on how to make good figures for your research articles. It's not so, I think it's not so famous in physics, but for example in biology, there are really people that are paid for that. So you go say, okay, I want this figure, I want to present this data, you propose me how to do that. You see? So it's important. The figure is something very important in your research. Most of the people will read the title, the abstract, and the figures. And the figures, usually, the idea is that is the caption of the figure is self-content also. It's important not to, I mean, you could try to force the reader to go to the main text, but at the end of the day, what happens is that they don't go to your paper. So it's important to have the caption, a very good caption on your figures. So here, the components are the data presentation. You will need to find some graphics or tables or whatever to describe what you have done, your results. And you also have the statistical analysis, if you have some, for example, if you have an experimental paper. So at the end, the guidance here is to be objective. I will make this is important issue to make the difference between the results section and the discussion section. So be objective, present the results as they are without inferring meanings or reason. Visual aids like graphics and tables can be very effective, but ensure that they are clear and well labeled and not so heavy, okay? So aquí, data in figures are the most relevant part of the paper. As I said, many people just jump between the title, abstract, and the figures. So it's important. Then you have the discussion that I said sometimes is results and discussion, but the discussion is really the part where you have to interpret your results. This is the part where you are like the physical discussion occurs here. So you interpreted the results and place them in the context of the existing knowledge. This is a very important section. So you have to encompass what is already known to explain what is the new and the value of your research. So is this a very important section? Here the components are the interpretation. You are interpreting your data. For example, your data shows that the original of the universe was not the Big Bang. Okay, so this is the interpretation of your result, and you put it in the discussion. And you try to make, again, a conversation with someone. Someone will be the one reading your paper later about why this is true, why this, how to say, your personal interpretation, so to say, is based on science. This is the main thing in the discussion. You can also do here comparison. It's very good. Like, for example, if you are, again, you are having a new quantum gravity theory, then it's good to you compare to the other models of quantum gravity. Okay, this one addresses this, and that, but does not address this, and that as this other model does, for example. It's good to comparison. If, for example, we are doing a squeezing in my lab, so it's good for us to compare. So we have reached 5 dB of squeezing here, and in comparison to this other system that reached this, and that with this other technique, for example. Okay, so comparison is good. This point that I have highlighted, the limitations, is very important, and I want to take some minutes to talk a bit of this here, that you have to acknowledge any shortcoming of the study in the sense that you need to understand, when we do science, we try to model something. And this something will depend on our sense, in the sense that if you are trying to model some quantum stuff or something in the really far universe, at the end of the day, you are using data from telescope, from microscope, and of course, every time that we have a better microscope and a better telescope, you can find new observations that change a bit the physics that you are trying to modulate. So science is a dynamical thing. A lot of people think that science is very like exact and like a square and like a horse, and you don't move like that, and you don't have the flexible mind to reach other things or to imagine different things. And for me, it's all the contrary. Science has to be asking questions all the time, and you have to be, you like a researcher, it's important for you to know the limitations of what you are doing, where and how, and what are the limits of your modeling. This is important, especially when you are trying to use the word analog. This is a very, so sometimes you see papers where they do not explain exactly what is the analog with this and with that. And this you need to pay a lot of attention, especially when people, for example, I had found some papers when they try to do some analog things to quantum mechanics, and at the end of the day you say, this is not analog. So you have, this is not explained, first of all, and then it's very like misunderstood what you are trying to, the analogous thing that you are trying to make. So at the end, if you want to compare, for example, that, for example, I don't know, in fluid dynamics, we can see the wave-particle duality by dropping a drop in some liquid, so then you see how the drop interacts with the own wave, and so you can have a quantum particle wave duality, for example. This, I'm not saying that this is not valid at all. I'm just saying that you have to explain very well what is the analogy. Is the analogy by Hamiltonian, like term-to-term analogy, or is like a phenomenological analogy? You need to explain that, and you need to be very clear on that to avoid misunderstandings. Yeah, this is important when you are presenting your discussion on the paper. So the recommendation here is part of the discussion where you can have some recommendation of further research or practical implications. Sometimes it depends on the paper, but sometimes you can have like a section of results, and then you can have a section of discussion and perspective, or some other people prefer to have results and discussion, and then another section of conclusions and perspective. Okay, but somewhere you have to talk about this. So the guidance here is, while interpretation and opinions are allowed, of course, when you are writing your paper and you are giving an opinion on the field, this opinion has to be based on something that has evidence, of course. And so be careful with the overgeneralizing stuff. At the end of the day, you have to be careful with the sensationalism in your own research. You want to keep it accurate, and you don't want to sound like you solve the problem of the universe, and then it's not true, okay? So this is the thing. So to understand the new, it is necessary to encompass the all, to show how our findings reduce to the all. This is important too. It's like when people think, not you, of course, but general people, think that quantum mechanics are in opposite of classical physics. No, quantum mechanics encompass classical physics. If you take average in quantum mechanics, you will see the classical results. So this has to be, it's the way of doing science. So where the new and the old differ, what is the new that is learning here, and the relevance. So all of this has to be included in your discussion. And then you have a last section that is conclusions, and sometimes people call it conclusions and perspective, but it doesn't matter the name. At the end, the purpose here is to tie together the various threads or the things that you have done in your research, and try to summarize the main findings and the discussions, and to open the path to new things. You will see that in all the conclusions and stuff, you have like the last 3 or 4 sentences about that. And this opened the path to do I don't know what. Or sometimes you can have also this phrase, okay, this is important to, we suggest to keep following this research line here. This was out of the scope of this paper, but it's important to discuss, to be discussed somewhere else. So all of this, it can happen on the conclusions. So here you want to highlight the take-home message. Again, you need to be, when you are the reader, it's very useful for the people who has written the paper to try to come back to the central idea that you want to communicate. So it's important to highlight again here the take-home message and show the door that is open with your findings. So here you have to synthesize key findings, broadens the implications and the direction of the future work. Okay. Conclusion should always goes back to the beginning, as I said. So you have to close the whole thing and make sure that the most important message of the paper is highlighted and show how this expands the horizon of knowledge. So this is like about the structure of the paper, of what we have seen, how you structure and how are the main ideas of each section of the paper. And now I will move a bit about the ethical consideration that you have to have when you are writing a paper. And I will end up this part of the lecture also talking a bit on the peer review processing. Okay. So about the ethical consideration here, the purpose is to ensure that the integrity, honesty, and responsibility of the researcher when conducting a publishing and publishing their work. So the key consideration here are the data integrity and authenticity. So you want to avoid falsifying something or to invent some data, represent the data as it was collected, acknowledge its limitation, as I say. So this is all part of the ethics. So at the end is that do not cheat. This is the thing. So this is very important. So I also, in Chile, well, all of us, more or less, in Chile, you have to do teaching and research in any university. So I teach courses in the first and the second year of the Plan Común of Engineering and Science. And I see a lot of students try to get the easiest way in order to approve their courses at the end, okay? And then this is before I remember when I was, the first years that I started to do teaching as a professor at the university, I really tried to find whether my students were cheating or not. And at the end of the day, I am just teaching this like in the normal class like this. So at the end of the day, you are responsible of your own path in learning how to be an ethical researcher. If you want to cheat here, remember that then in your master or PhD, you could be cheating in adding a data or taking out a data because it does not fit what I want to show. So at the end of the day, this is up to you, and you need to be ethical on your work, period. So no one will be like, we are not cops trying to see whether this was well done or not. This is not the idea of the reviewer either. So you need to have a good ethical work ethic, so to say, okay? Of course, you need to, this is an important point, the authorship. So you need to acknowledge the people that have worked on your paper when you are like publishing a paper. So include the people that should be included there. This is a topic that is complicated because I know that in some groups they try to include everyone in the paper. It doesn't matter how long has been in the lab or in the team. And I'm not saying that this is wrong. It is what it is, but just be fair in what you are doing. And if you think that someone should not be in the authorship list, then at least acknowledge them in the acknowledge section. Like we think, for example, as I said yesterday, in the JQI, they have this practice that when you finish your paper, then you send it to 3 other professors on the JQI, and they act like the first referatums of your paper. So then, for example, when you are actually sending the paper to the journal, then you put their names in the acknowledge. Like we thank Professor whatever, to take the time to I don't know, to make good feedback to our research or rich discussions on the topic or whatever. So if you think that someone is not like in the level of the authorship, then ask yourself if it is worthy to acknowledge them in the acknowledge section, okay? Of course, you don't want to do plagiarism. This is obviously, but it's always very good to remember. You don't want to have duplicate publication. I don't think that this happens anymore because now everything is like online and very fast, so it's weird that you have this duplication and stuff. Of course, you need also to consider the conflict of interest. So when you are, in some journals, when you are publishing a paper, you can suggest people to review your work, and also you can suggest names that you don't want them to see your work because you have ethical problems or something going on that is hard for them to give you your work like an unbiased reviewing. Okay, so you can also do that, and you. For example, in projects, this is more. I think it's more common in projects, at least in Chile. When you are writing your own project, you have a section where someone is asking you, okay, do you have some names that you don't want them to see or to evaluate your project? And this is fair enough. You can put the names if you don't feel comfortable with them to see what you have been doing or what you are proposing. And of course, this is not such an implication for us, but the treatment of the subjects, you need to be paying attention to that. And this also I wanted to stop by here a bit because at the end of the day, you are doing great science, right? I think that we all come from good teams that are doing the hardest they can to to like expand the horizon of knowledge on the field, and we are trying to do the best we can. But at the end of the day, if the people who is working with us and not for us are like treated badly, or they do not feel like, I'm not going to say the happy word, but like happy or comfortable doing the science, because at the end of the day you are abusing somehow of them, this is a problem. This is a really big problem for me. You need to know how to have a healthy leadership. And I say this to you because you might be in a position where you feel this way, which could be happening here, and then you need to find a way, I think, to put these like healthy limits on your topic, on your research, on your work, okay? But at some point, you will also become leaders. And you need to know how to lead healthy to your team. So everyone wants to publish as much as we can, the best we can, in the best journal. But at the end of the day, if the people that is working with us is not having a good time, then you have to think twice on how you are doing things and how you are like guiding your own research, okay? So this is an important thing to me. And think about the common good of the training process. I think that has been lost a bit. Of course, this is my personal opinion. You can differ. But I think that in some groups, the main point is to publish stuff, but not the training process that is as important like the output of your research. So we cannot lose that. We are forming people that will keep going the research in our country, in our team, university, whatever. So it is important to acknowledge the training process. And of course, for us, it will be we will need to spend more time with you because of your training process. So it will be that we spend more time in the lab explaining things 1, 2, 3 times, or helping you to write your first draft, or trying to see, okay, you want to apply for this scholarship, so we will have to review your scholarship. But this is good because the training process is as important as the output of the research, okay? In my personal opinion. Then, the last part that I wanted to talk today before we go to the enhanced part is about the peer reviewing process. At some point, you will be reviewing other people's works. Actually, in this course, when I have more time, like in the semester in Chile, at some point, the students do these 3-minute flash talks, and then they prepare their own paper, work, whatever. And then we have to switch anónimamente between the mates, and then have to review the paper of the other one. So we are trying to teach that also in this course when I have more time. So at the end, the purpose of the peer reviewing process is to evaluate and validate the quality, validity, and relevance of the scientific paper before they are published. So it serves for the quality control. This is the peer reviewing ensures the work meets the scientific community standards. Credibility, the peer reviewing paper has undergone evaluation by experts in the field, leading its credibility, and the feedback for improvement. This is a very important thing. You also expect, or I expect, when someone reads my paper and sees possibilities to improve my work, I'm really hoping for them to bring that up. In my personal opinion again, but it's something that I try to do, okay? So the stages of the peer review is something like this. First, you do the submission. Normally, a lot of people, we submit the paper, and then the same afternoon, we send the paper to archive. So it will appear in archive like 2 days later than the date that we have sent the paper to the journal. Or sometimes also some people wait for the editor of the journal say, okay, good to go, now we will send your paper to the peer reviewing process. Because it could happen that you send your paper to whatever journal, and then the editor said to you, but no, it does not meet the criteria of whatever, so it will not even pass to the peer reviewing process, and this can happen, okay? But somewhere you submit, and then you put it on archive. This is more or less the idea of what people try to follow. Then you have the preliminary check, that this is done by the editor. So the editor sees your paper, sees your work, and he decides, or she, whether this goes to the peer reviewing process or they stop there because of whatever. And they will send you an email saying, your paper is very good, but it does not meet the whatever scope of the journal, okay? And then they go to the reviewer selection. So the editor will find, hopefully, 3 people to read your work. This almost never happens because there is we are not paid by that. So at the end, everyone is super busy with their own lives, and we try to help, but at the end of the day, it's very slow, the process, okay? But at the end, so the editor will choose people to read your work. And then it will be the reviewer time, where people will value and evaluate your paper, your methodology, all the things. And then they will send like a report, hopefully more than 1 paragraph, in order to say to you, okay, your paper is good here, here, and here, but it's lacking of this, and that, and it should be improved because of that, and whatever. So then you can have different answers. You can have an answer say, okay, this is super good, just publish, doesn't need any change or whatever. You can have another answer which is, this is good, but it has to be changed this, and this. You can have other answer which is, I don't know if this is so good. So first, before like having my mind clear about the publication value on this journal, I first need for them to improve this, and that, to give me a really good idea of what they have done. Or you can have another answer that is, no, this should not go there, even if they fix it. It still does not meet the criteria or whatever. And then also, at some point, us as a reviewer, we are asked if the paper should be published there, and if not, if we suggest another journal also within the journal, como APS, Óptica, whatever. Okay? Then, so you will receive your reviewing. Then you can go one, normally, if you have, for example, an ambiguous answer, then normally the editor allows yourself to go back, fix whatever is being fixed, then submit a new version, and then submit like the answer to the referees. So this normally happens once. It's weird that you have a third iteration with the peer reviewing. Normally, when there is like a second round, normally then the editor decides. Okay, so then you have the decision. So the editor will decide whether he accepts or not, or she accepts or not your manuscript, and then you have the revision. So then when when your paper is accepted, you will meet another part of the team of the journal, and they check like line by line, figures and everything, and they say to you, okay, you need to fix this, and that, or whatever, okay? And then it's published at the end of the day. And this can take a long time. So I also want you to know that, because I know that when you are writing your first papers or the second or whatever, you are really excited about the paper to be like published, but at the end of the day, it takes a long time. And that it is what it is. It's hard to fix that. You have some, well, I will not go there, but maybe you have some other journals that are not so good and they are fast and you pay a lot, but that's not the idea. So, well, you have to keep that in mind. And so it can take a while. In the ethical consideration of the peer review, hopefully you can be impartially. So this is hard. I want to here again give my personal opinion on that. But this is hard because it's not blind. So you know who has been like, who did the paper. They don't know you, but you know them. So it's hard. If you receive a paper for a Nobel Prize, it's hard for you to say, no, I do not agree with this. I don't think this was well done. It's hard to be non-biased about your own reviewing process, okay? So in my opinion, should be blind. And worse, once the paper is published, I would suggest to put the evaluator names also. Like, this paper was reviewed by someone, the person. I think that this is way more honest at the end of the day. And you know who has reviewed and who has checked this paper before and everything. And I also try, when I am the one reviewing a paper, I try to give a good review, not a paragraph saying my personal opinion of the paper. This should not happen. So then the editor is the one saying to the reviewer, you cannot send a paragraph of your personal opinion. I have not asked you that. I have asked you to evaluate the paper. So then you don't do it. It's better, and then you save at all time. You see? So this is important. Then confidentiality, of course, you need to keep the thing by yourself. The idea is not to share the findings of other group that the findings is being evaluated, although you have the option to do the peer reviewing process with someone else. when you are going to upload your review document, then there is a section that they ask you, have you done this by yourself or someone was helping you? And it's okay. For example, I try to be help or train my students, for example. So I try to say, okay, this student, this is very similar to your topic. Let's try to train you in this peer review processing. Or the same I do with the postdocs, for example. So then I just add the name, and that's it. There's no problem. The timeliness, this is important. Of course, try to keep it within the time that the editor has asked you to do. It's hard. I agree, it's super hard. The conflict of interest, this is also about the ethical part of the reviewer. If you know that your evaluation cannot be unbiased, then say no. It's better, okay? And try to have a constructive feedback. This is something that I try to do a lot. I try to see the good of the paper that I am receiving. Sometimes I cannot, like really the paper is not well written or the findings are not conclusive. But then again, I try to say that in a very good way. Okay, so I find that whatever is not done in the proper way. I think that you have done, you should do more deeply this part, whatever. And if I find a paper that it might be good for the journal, but it's not in that stage there, I also try to give a good feedback for them to improve their work. I try to have that in mind all the time, to see the good of the paper and try to help in that sense, okay? This is, again, a personal opinion. So now we will go to the hands-on part. So do you have questions up to now? Oh, okay, yeah, Leticia. Uh-huh. See, it's in the next one. Ah, no, it's not here. Ah, see, there. Here. Yeah. So okay. So yeah. So Leticia is asking how we can use this box, this audience box, in order to build up the presentations for tomorrow. So what I am expecting of these presentations for tomorrow, these flash talks of 3 minutes, is for you to take a paper or your own research, for example, your poster or whatever, take something, and then from that extract the broader problem, the narrow problem, what they have done, and the key implications and perspective from that paper or work or whatever. So in that sense, for example, first you know your audience. You know the audience that is here, so it's most master or PhD students on your more or less on field. And then, for example, when I say the problem, the solution, for me this is the broad and narrow problem, and then what you have done, what you are solving. So for example, the problem will be, what is the broad problem of your community? Then what is the narrow problem that you are trying to solve in order to help this whole problem of the community? And then the solution will be, after you present, I want to do this, that this solves this narrow problem, so to say. Okay? So this is the idea of how to use this box. Of course, as I said yesterday, I am giving you tips, but at the end of the day, you need to be comfortable on the way you are presenting. And the most important thing is the flow, okay, of the thing. So well, now the idea in these last 30 minutes is to work on this. So you need to work now in your 3 minutes presentation. If you don't have your computer, that's okay. Just take a paper and start doing something about the broader problem, narrow problem, or whatever paper or topic that you decide. And the idea is, for now, I will have here, if you can come at some point, and I can write down your name, because I want to have the list of the people that are willing to present tomorrow. As I say, I don't want to force anyone, but I truly encourage you to take the opportunity to do it. And then I will ask you to send me the PDF presentation to my email by the latest tomorrow, 9 a.m. for me to be able to download all the presentations and to put them all together. Because if we wait for everyone to connect their own computer and stuff, we will not have the 30 presentations. Okay? So this is the idea. So keep in mind the box, keep in mind how to create the value, and keep in mind this broad problem, narrow problem structure. So yeah, so I will just, I guess they upload the classes, right? Because, so everyone has now the access to the lectures, so it's easy for you, but still I will let this open here. So now the idea is for you to work in this half an hour, and then you come here and you write down your name for the presentation tomorrow, okay? Ah, okay, good, yeah, okay. Who is working in theory? Who is a theoretician? Okay, it's kind of the half, right? And then who is the rest, I hope, is experimental or in simulations. It could be also numerical stuff. So who is experimental? And simulations? Or more like, okay, numerical stuff? Okay, so you have like a mix. Mm-hmm.
So in the beginning, Carla mentioned the archive and that you should be following the archive. How many of you do this? How many of you look at the archive or what is it, SciRate, these different platforms, or do you receive the archive email? How many people look at the archive, say, daily or at least weekly? Yeah. 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 It's,
Weekly.
I mean, so when I was a master's student and I discovered the archive, I saw I could subscribe. So for 26 or 7 years, I've received an email every single day with all of the papers. And so it's quite nice because you're on the metro, you're on the bus, you're having a coffee, and you just open your phone and it's right there and you can read all the titles. And like in my opinion, you cannot underestimate the amount of, let's say, awareness or knowledge that you learn from just osmosis of reading, you know, what used to be only, say, 10, now it's maybe 30 titles, and maybe the first few sentences of abstracts. You just have like a general, you see some key words, and then somewhere down the line, someone mentions something, and you say, oh, I remember a paper, and I remember someone was on this paper, and it's really important. It takes, you know, 1 minute per day, but it's really, really important, and yeah, so yeah. I was happy that when...
So my suggestion is to spend the first 10 minutes, 10, 15 minutes with the coffee while the computer of the laser is turning on, because it's a really good habit. And also, it helps you when... Okay, I don't know how to turn it. Okay. For example, you have published your paper, and then you see another paper very near your other paper, and they do not know that you exist. So when the paper appears in archive, you still have time to write down an email and say, hello, I am whoever, and I have been working on this, and then you normally send an email saying, I found your paper very interesting, and I just want you to know that we have done whatever, and maybe this can improve or enrich your introduction. At the end of the day, you are saying, cite me. This is the thing. But of course, you cannot just send an email and say, cite me. So you like to cover a little more beautiful. But this is important because some people do not cite you not because they are mean. It's because we are a lot of people doing stuff, and we don't know each other. And that's why it's important, again, the archive. Mm-hmm. Sí, but wait.
So one more comment, and this is for maybe your mental health. Nowadays, I mean, you are all very used to social media. You're on Instagram and all these things. But when I first subscribed to Archive as a student, I felt in the beginning sort of very overwhelmed because every day there's, 15 papers of doing all these interesting things. And I said, wow, I'm not doing anything. Maybe I didn't even publish a paper yet, or maybe I published one paper in the last year or something like this, and all these papers coming out. And so just be aware that it's, don't compare yourself with the rest of the entire scientific community, right? There's, thousands of people working in your field. And so, yeah, I mean, you're maybe more used to this than I was when I was a student. I mean, like I said, you have social media and you have so there is this social media aspect to the archive that, you should go easy on yourself in that regard.
Yeah, I agree 100%. Anyone has any other question before? for the hands-on part? Wait. But wait. It's just for them too.
Thank you. It's the last, I swear. No, it's because there's something that I do also that helps me a lot is to activate the Google alert for some names. For example, I don't know, for Steve or for the other professors that work with me, I have a Google alert activated. So I receive in my email all the papers related to the research of this researcher.
Claro.
And the correlated one. So sometimes I receive in my mail papers that are not an archive or in other parts. And it's very interesting. So it's like filter something.
Yeah. I think that ResearchGate has the same thing.
Yeah.
When you are like, if you go and do yourself a ResearchGate profile, and then you add, I think that there is a part where you can add people that you want to follow or something like that, then you receive some alerts on the ResearchGate. And it's really nice because I think it's there where you also see your own work being cited. So you get an email saying, whoever cited your work, and you feel super happy. And then you know they also, because maybe, again, you don't know them, but they, for some reason, know you. And then you can start to see, okay, this paper cite my work, and they are doing that. It's very interesting and whatever. So it's important that you can.
Yeah, it's a comment, actually. If you want to subscribe to the archive, it's really easy. You only send an email, and it wrote like 5 lines, and I'm going to get the summary of whatever index I'm interested about every day. So it's basically just an email. Do that. Yeah. It's easy.
It's easy, and this is a good habit. I mean, I work with another professor at some point, like collaborating in the University of Oklahoma University, yeah. And he's really tough. He's really but he had like the meeting, the group meeting was a 4 or 5 hours meeting, where the guys went like one by one, say what you have done, blah, 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 in your own research project or lab or whatever, and then they have a time where each student has to bring up a paper. Which paper have you read this week? Why is this important paper for whatever we are doing? So at the end, it's really a good habit, and it's good to learn how to summarize. This is something that I forgot when I was giving the lecture today. Yesterday, I gave, the first lecture, and then some people are watching us there in the internet, and the student was watching the lecture, and he said, okay, this is really good because I am trying to find a PhD position, and the first thing that the new possible PI asked me is to summarize my thesis in 5 minutes. And then another guy from here yesterday, he said, I have to do the same next week in 20 minutes. And it's not easy. It's your work that has been done the last 3 years, 4 years, I don't know, and you are asked to summarize your thing in 3 or 5 minutes, or 20 in the most, and you need, again, to build the value of your thing, because you want to convince this PI that you are a good option for his team or her team. So it is important to know how to do this stuff, okay? Any other question? Yeah, gracias. No? Then now go, please, and keep working, and you have questions, I can just go to your desk or sit.